Hello and welcome again to the second installment of this playlist where we'll explore spinning and provisioning infrastructure with the help of Terraform in Google Cloud Platform. Previously, uh, we had seen that how we can spin up a resource, and we took uh, a storage bucket as a resource to spin up according to um, our specified uh, location name, and we also went ahead to add labels to the bucket. We did understand, we did talk about few of the components, necessary components of Terraform, and which provider being the first one and the most important one, because that is how the the engine, the Terraform uh, behind the scenes logic understands and authenticates to spin up resources in your in the from the provider block. The provider block also has three required attributes, uh, namely credentials, projects, and region. And we did see in the previous video that I posted how we can get hold of and create those keys and give permissions accordingly uh, to spin up and provision resources inside a project. Um, Today, I'll just first show. Um, mm, yeah, I was watching Prime. That's fine. I like Doctor House. Olive Tech demo bucket. This is the one that we had created with the labels dev and DevOps. Looks good. Actually, by the end of the previous video, we had shown how to destroy your resources as well, but then I went ahead and recreated it for this second installment. Um, so in today's we'll touch base upon few things and few concepts. First of all, we'll try to spin up and provision an instance. We'll see how we can do that and where to find the necessary documentation and the um, configuration block hash in HashiCorp configuration language. We can easily find that in the docs under the provider Google. Because we are spinning up the instance in Google Cloud Platform. We'll then move on to see how we can use another component, which is the variable component in Terraform, and how we can start towards automating and um, referencing different attributes, IDs, and um, uh, names within our template. So it's not just that uh, if you have known the concept of nesting within the template within infrastructure as code, which CloudFormation provides, and I guess deployment manager and ARM templates also provide. Terraform also provides nesting, but it does it in such an incredible and robust way that you can reference the ID, the attributes within the same script in the same infrastructure as code script that you want to deploy for. So we'll touch base on that as well, and mostly I'll be doing it live. I'll be recording it live, so most of the things that I come across, they might fail, they might get error, but the intention here is to just explore and get known to the relationship between Terraform and Google Cloud Platform. So moving on, we'll jump onto the um, Terraform documentation and look for Control F, Google compute engine resources, yes, and then we'll just first of all try to deploy a default instance. Yeah, the example usage block, we'll copy this first of all and then paste it here. just save our file, and let's just go back and go through the block. So the block says that the resource type that we are trying to provision here is Google Compute Instance. That will be a Google Compute Engine virtual machine. The name of that instance that they want to keep in this example is default. That is the resource name that will be identified by Terraform. The actual name that will be on display in Google Cloud Platform will be test per this example usage block. The machine type being N1 standard 1, zone is US Central. Now this is something that when I'm going through it, it doesn't suit me, because I would like to keep my zone in Asia, but I also know that there could be a possibility where I would require to launch the same demo in another regions. So I know, while reading this example, I have the understanding of cloud infrastructure as code, that are templates. When we talk about templates, and when we talk about um, infrastructure as code, basically we deploy infrastructures with the help of those templates, and those templates they provide a, a ground base to for us to build upon. So if you want to keep everything central in Asia and then fan out your deployments to different regions, Terraform does give you the power with the help of variables, that you can for now the zone is being hard coded and called as a string, but instead Terraform gives you the power that you can substitute a variable here which can be dynamic in nature, and we'll see that. Um, Moving on, so they have the example usage resource block has applied some tags. Boot disk is required for the compute instance. So if you scroll down, you'll see the required sections and the required attributes, and you tailor your templates accordingly, according to your need. Um, so we've picked up and we've checked the required sections. We'll just go through them again. Boot disk, machine type, name, zone, network interface, optional, um, optional. Yeah, so I guess everything above looks good to me. For to spin up the infrastructure, I just need to take care of. I need to script network interface, zone, name, machine type, and boot disk in my resource block. So rest everything I can take rid of. I can get rid of. So first of all, I'll just remove the service account. We'll come and touch base to that later. I'll remove the metadata section as well for now. Well, I'll show what access config will do for us if I uh, comment out this block. I hope this is commented out. Yeah, this access config is an attribute or further property of the network interface, which will do which will explore later what it'll do for us. But for now, we'll just stick to default. The image that this instance will be using is Debian Cloud Debian 9 image. The tags foobar. I didn't use tags previously, so I'll just stick with the labels. I'll remove tags from there and apply labels. Yeah, that looks good. So I'll go ahead now. I also need to change my zone. First of all, I'll just do a simple deployment. I'll change it to Asia South 1A. This is the region, and I'm going a step ahead and declaring my zone as well. And this is a good opportunity I'll take to discuss and bring in the concept of declarative and imperative style of infrastructure as code. This is very much declarative, and Terraform tends to understand the declarative uh, style of infrastructure as code more, or say it tends to be on that side more, because here what we are doing is we are actually going and defining our infrastructure specifically with our specifications, and deploying them at once. Now, uh, if I have to give an example, um, these the template, when we request through an API to Terraform that we are trying to um provision a resource of type Google storage bucket. Terraform is smart enough to understand, and they identify this resource type within their database, and they have a template, they have an understanding behind the scenes for this particular resource type. So what they start uh, doing it, that's all an analogy that I prefer to going into analogy to understand the mechanism better. So what behind the scenes Terraform starts doing it knows, as soon as it reads it parses this from the API. It knows that the client is asking me to get ready with the template of Google storage bucket, and now within that storage bucket he has also given me the name that the client and the remote, that is the Terraform behind the scenes episode, they also identify that resource that is of type Google storage bucket. And then it comes to our specifications and the required keys that are required to spin up and provision that particular piece of resource. And this is also does make sense, because if you see, because clouds are nothing but pieces of infrastructure that we try to grab from the data centers. So I'm just uh, trying to grab a storage piece of resource which I have named, and I want it to be displayed as this, and this as of now is in the default network under the Google Cloud platform, but still not open to the world. So basically, trying to touch base on the concepts that's rushing into my head. All right. So what we'll do is we'll Terraform apply. No, we'll do Terraform validate, sticking to the traditions and the norms. Looks good to me. I'll take a chance. Oh, first I'll just deploy. Yeah, we'll do that all together. Terraform plan out equal to deploy VM in Asia. ATF plan. What we'll do is we'll check what plan what's the plan that it tells us that it's got for us to spin up the resource. All looking good. It says it'll spin up a compute instance with the name default, and we'll go ahead and apply these labels. The machine type, as we have scripted in our infrastructure as code, specifically we want is N1 standard 1. I'm so sorry for the noise from outside. Uh, we'll go ahead and apply this plan and see if it spins up the resource as specifically in a declarative manner done by us. Yeah, it'll take about um, well 21 seconds it took. Um, Also, I would like to reflect now. This is the reason that I've just scripted everything and I've spun up an instance. If you take the other way, if you take the other route and spin up an instance, because this is a very uh, high level example of spinning up resources and infrastructure and deployments. But if you go ahead and then when your infrastructure starts expanding and your application or whatever workload that you are trying to get achieve your business derivatives from, when they start to expand, you would like to use a repeatable process which is consistent and give you predictable results, um, which is where infrastructure as code comes in so heavily, and it becomes such a necessity um, to keep up the agility and speed, to give speed to the development process of the application overall. So we'll go ahead and check our deployment. We'll go to compute engine, and yes, that's there it is, our test instance. If you go ahead and check the labels, they'll be again verified. The machine type is N1 standard N1. DevOps looks good, and we'll go ahead and destroy it. This will also go ahead and destroy. Oh well, what I can also show you now is Terraform destroy. That should be, I always prefer to use with the target flag, where we can target a particular resource. So if I target and destroy Google Compute Instance.default, which is the resource name that will be identified by Terraform, this should go ahead and destroy only the instance but not the bucket. And if I use the command terraform destroy, just terraform destroy, it will destroy all the resources that are currently present in our state file. So what terraform destroy target will do, it will target the state file and then look for that particular resource and then destroy it. It should prompt me, yes, just one to destroy, not two, though we have two resources. And if you'll check your state file after this destroy, you'll see the resource, which is the bucket resource, which will be still present there, but there'll be no instance. It's amazing the decibel levels, even while quarantine, is amazingly high here in India. I'm recording this from south of India, but it's not. I've been working more or less 8 months now, working from home. I'm not sure, but it's a good opportunity to polish our existing skills and to learn and to get on to learn new skills as well. Still destroying. It's relatively quicker, but we can see that's the shutdown process. This instance is being stopped. So that was a very general example of spinning up an instance. As soon as this destroy is completed, I'll go ahead and show you a few other things. That I'll also show you how we can make use of the variable component in Terraform and substitute the values accordingly. Wow, that is bitter long. Meanwhile, I can actually show you in the meantime. Now, when my manager when I went to the manager and I showed him my script, he was very happy that I did something with Terraform, and now they do not have to completely rely on their cloud native um, infrastructure as code automation tool, but they can move away from that tool and explore the opportunities behind using Terraform. But he is not really happy that I've been passing these credentials uh, in this manner, in a hard coded manner, because what he suggested it is, if we keep, and he was also not happy with the specificity of these resources. He suggested that if we could use this template with our China team or with our Korean team, they would be really very happy with the infrastructure, because as of now their team is lacking behind in infrastructure as code skill set. And if we can make the infrastructure a template in such a way that they can spin up the infrastructure of our desired app, they can take care of the marketing, and they have a robust marketing team, or whatever analogy you want to make behind it, you can. So that's, I understood, and it makes sense. So I was very happy with my leads inputs on this, and now I wanted to explore more of Terraform, whether Terraform allows me to do that or not. And I found that Terraform has a component which is very friendly, called um, the variable component. And how do we introduce the variable component is that we do a variable. I'm sorry. We just script variable. Uh, we give a variable name. Let's say we name it path, and we then start assigning properties that we want our variable to look like. Um, so in this case, our variable, I want my variable to be a type of string. It could be a type of numbers, integers, strings, alphanumeric, and there are lists, a lot of things. And the default value I want to keep for this path is the path that I currently have my secret in. And I'll just substitute default this here. Default path to Terraform SA secret. I'll jot that in, and I'll save my file. What I'll do here is I'll just comment this bit out. Sorry, I had already prepared this, so I'll pick this up and we'll discuss what I did there. Okay, yeah, I'll just remove it from there, just in case if it doesn't go, the demo doesn't go well, so I can fall back on the on the same thing. So yeah, what I did is I substituted the credentials value, the key credentials key value, as a as to be a dynamic, and the way we pass dynamic path variable, the same way I'm passing the dynamic value. So to pass a dynamic input value, we use $sign, um, and I have an analogy that we use $sign because it floats. Dollar floats. The money floats. That's the only thing floats. And then we substitute and make use of the variable, the very friendly component of Terraform, which is variable. And we point it, we ask the variable. It, sometimes I think this acts like a class, and within the class, then we are calling the objects. So this variable then calls the object, path object, which Terraform can identify with the name path, and which we actually gave the default value of the path to this particular file. Okay, there's okay, let's go ahead and test this out. I think this should not work, and we'll explore why. Terraform validate. It should validate invalid expression. That is because of this, and because I need to quote whatever I am trying to pass as variable. Yeah, so I'll just pull this in double quotes, save my file, and try to oops, and try to validate again. This should validate, but when I apply, this will plan as well, but when I apply, I'm pretty much sure this will not apply. There's a reason. Yeah, so Terraform plan out deploy var path tf plan one provider error loading credentials read. We just substituted the path. We never the path, it doesn't contain the file, so we never gave the file name. We just substituted the path. So this I specifically wanted to come across this error because this specifically shows two things. First of all, the great ability of Terraform, and that's it exactly exhibits the reason why it's so popular. It's because it gives you the error message that you run across in your template. It's and that error messages are pretty much like very helpful, that allows you to build your infrastructure very quickly and very easily. uh, so so one reason is that of the error messages that they response back with. The other the other um, the other great thing to notice here is that um, even while declaring the variables, it's very specific to what you're trying to send in the variable. So let's say I'll just I'll just copy the file name as well and add it to my variable there. Change the variable from path to secret. There goes secret, and now, and let's try. Basically, we didn't do anything. We just changed the name of the variable and added the file name right in the end, uh, expecting that this time we'll not get the error of authentication. So Terraform, what we'll do is we'll do a good thing that we have the up arrow, and then we'll apply. I think I was not able to even plan. So looks like the variable substitution is working perfectly because it started creating um, a resource. The resource has been added. We'll just verify that. If I refresh, oh yes, there it is. So just something that to look forward for is that you can use variables for everything now. Now that you understand this, so say I'll use a variable here for location. So I'll go ahead, variable name, which is um, default location, and I'll type type will be string, uh, default will be value of uh, Asia, and uh, that's about it. Description, if you like. Description. We'll make it interesting. We'll just do the description as um, default location for all deployments using Terraform. And we'll go ahead, just for some fun, we'll create another variable which will say client location, and that's EU. Very much possible. And the client wants that I want to have my storage bucket in Europe, so we'll do var dot client location. But our development team sits in Mumbai, so they want to stay with the zone here. In that case, we can substitute the value. I'm not sure if I can do zone, or I can, yeah, let's try to substitute that. Var dot default location. And one more thing to notice: if you have had any experience before Terraform version 0.12 or version 12, I'm not sure. That version, wait, sorry, that is really lazy of me. Version 0.12. Anything before 0.12, I guess they used to have these quoted, the strings and the values had to be quoted, but with Terraform 12 onwards, 0.12 onwards, that's not really necessary until and unless you want to specifically want your data to be parsed as you have input. So so this should recreate our bucket in location. Yeah, this will create a bucket location in EU and an instance with our development team which resides in Mumbai in Asia, because we have a differentiation of client and default location with the help of our friendly variables. Hang on. Okay, so Terraform validate, looks good. Terraform apply. We'll not make a plan because this is just a demo. We'll just apply that, and yes. Let's check. Should be creating again. Now this is created appropriately because I wanted it to be in the Asia South 1 region. That looks good if it's getting created. And let's hop and jump on to check our storage bucket should change to EU. I'm so happy. Let me just verify again. It's still creating. We'll wait for this. So far we touched upon the components, variable components. We have seen how infrastructure as code works. We also a little bit discussed about declarative and imperative styles of infrastructure as code. um, how we can use variable substitution and expand and fan out a generic template for various deployments. um, Meanwhile, yeah, also one more thing to notice is the network interface. Let's just do this thing as well. Now, when this instance comes up, this instance I'm expecting it to have no external IP, because that's what I'm trying to. Wow, I think my deployment is still going on, and no error loading zone Asia. I wait. What I'll do is default location Asia South 1A. Oh, that was in EU South 1A. Yeah, that looks good. Also, this will also exhibit that now that uh, the bucket was actually created, but it was not able to recreate the instance. It was able to destroy it, uh, and it was not able to recreate it. So this is something which we can also specify in in our uh, our template, that with the help of depends on and conditionals, that if the new resource is created, do not uh, recreate or destroy the previous resource. We can also mark down resources forcibly, that will avoid recreations. So those are deep dive concepts. We'll touch base on them with Terraform later, but good example to show. So as of this moment, I'll just verify again that my bucket is in EU and try to deploy with the modification that I had to do. Yeah, with the modification that I had to do in my script. What I did was, uh, this is a particular format of location that you can pass for only storage buckets, but otherwise else the format pretty much sticks to what I did for client location. Sorry, for default location, Asia South 1A. Try to Terraform validate. Looks good. Terraform apply straight away. And this will not go ahead and create the bucket again. It will just create the instance, because that is what is idempotence means. Terraform has no reason. It'll check your current state of configuration from tf state file. It'll find no reason to touch the bucket, because uh, it's there. It's with those uh, those specifications there, and that's why it'll go ahead and not touch that bucket. It'll stay as it is, but deploy just the instance, which is the property of idempotence. It's a it's a jargon thrown around a lot, but when you're thinking of different deployment approaches, um, then it becomes really handy, this concept in infrastructure as code. Deployment complete. We'll just check the deployment and refresh the page. Looks pretty neat to me. So use of the power of our friend in Terraform friendly component called variable. So we have substituted the secret as well. Looks good to me. I think uh, mm, what I can do is, if I copy this from, this will also work. this will also work for sure, but it gives us more uh, because we are calling this value as a dynamic value, so it gives us the opportunity to change our keys as often as possible. And then you can in the background you can deploy a Python script to keep uh, checking the key with the database that you stored this key this um, identification in, and every 15 days you can run a Python script that can change this value with the database. So a lot of things that can be done to automate um, and start introducing automation concepts, which is really helpful for someone who's looking forward to DevOps. Now this, when you see, it has got an internal IP because we kept the network interface as default. Now, in case if you require an external IP, that is where sorry, that is where access config comes in, and you just need to apply access config and keep it empty, and it'll pick up a public IP available, and go ahead and attach that IP to the instance. So we'll do Terraform apply again, and we'll see what behavior does this do at this point of time, because even for me I should learn whether this will first destroy the instance and then recreate it and then attach the IP, or will it just attach the IP straight away to the existing instance? If we refresh, nope. So we should be seeing an external IP attached to this very soon, because in the background it's just doing stuff with its network interface card. I guess it looks it's applied one change. It didn't change here. Okay, access config. Yeah, there it's our external IP. So we initiated, we attached an external IP just by passing the no value or no data, and just by attaching access config block under the network interface as an attribute. All right. So I think that's again. I don't intend to make these recordings so long, but I don't know. I just keep going with the flow. We'll keep looking into more plans and ways to implement automation and break out our environments and our deployments moving forward. Uh, but this today I just wanted to emphasize upon the variable and how it is such a good component and such a component. You'll find the same you'll find the same things in other infrastructure as tool infrastructure as code tools as well. In ARM, Azure Resource Templates, Resource Manager templates, we have the parameter sections, which is exactly like this, as what variables do. But then in Azure Resource Manager, they have the variables which run inside to run the variables to run inside their template, uh, which is a little bit abstracted in Terraform, because it allows to do it with the same the variable component all in one. Uh, so in the next video, I'll be looking how to bring order to your deployments, and we'll try to expand on our current template and see how we can start including things like and start connecting pieces of the resources to come up with a infrastructure that will be used in a solution. Say we'll try to deploy a solution where we'll be using different components like uh, job scheduler, like cloud functions and these things, and we'll try to commit to a solution based quest. Thanks everyone. Thanks for being so patient, and I would really love your comments and inputs and suggestions on the videos and the effort that we are doing here.